Now I'm going to assemble the rudders. To do that, I'll take the 1/8 inch shaft for the rudder, and then it sort of goes through. So this is the top of the rudder, this is the bottom. The shaft goes through, and then there's a recess to do a 90-degree bend. The rudder and the shaft are locked together. So to assemble this, I'll just put a 90-degree bend in this, and then I'll just put the shaft through with some epoxy. Also put the tubes for the rudder. So there's just holes in the back already lined up. So I'll just kind of put those through with some epoxy as well to hold them in place. Okay, I bent the rods. You can see there, a little modification. So first I kind of drilled these out just to 1/8 inch, which is the size, and then see I ground away a little radius there on the corner just to account for the radius. Next up in the build, I'm adding bilge keels. I have a separate video that walks through this, so I won't go in detail. But for plastic, I think the big thing is to kind of rough up the surface a bit beforehand so the fiberglass and the glue sticks. So I'm optimistic, hopefully this will work. I'll pick back up once these are done. I finished installing the bilge keels. They seem to have gone on pretty well, just using the same method that I use on putting them on a fiberglass hull. Of course, see if they hold up. For more information, just refer to that video. Other thing I did was I added on the drag shafts. So I just cut a small piece of tubing and grinded it down to fit the hull shape, and then put it on this 6/32 screw, which goes through the support here, and then put some epoxy filler in there. Now I'm going to install internal armor. For this, I'm going to use two materials. I'll use shower pan liner right here, and then pet resistant window screen or door screen. Both of these have been used successfully for a long time. We used to use shower pan liner for almost all internal armor, and then more recently the pet resistant screen has been the most common internal armor used. Both of these you can get at like a Home Depot or Lowe's. Okay, I'm going to use the shower pan liner to protect these solid areas at the bow and stern. It's going to do two things. One, it'll just protect that area from BB strikes, because the BB strikes will eventually ding up the printed material here. So it'll protect that, and then it'll help dampen any rebound off of the plastic. So the plastic by itself is pretty hard, so if a BB hits this, it's going to bounce back with pretty good velocity. So this will help dampen it. So just a little piece for the stern there, larger section on the partition in the bow, kind of cut a piece in like that, and then I'll just glue this in with the E6000, and that'll, like I said, kind of protect and hopefully minimize those bounce backs off the partition. Alright, and then the remainder of the portion I'm just going to do with dog screen. I have a separate video on that, but basically it's just kind of cutting it out and then gluing it to the bottom of the subdeck area here. I finished installing the internal armor. To attach it, I'll just put goop on the upper edge, and then I clamp it to the subdeck as shown here. Curves up a little bit, but once the internal components go in, it'll hold it down. Alright, and I do this at this stage just because next stage is to get ready to start putting in some of the internal components, so it's much easier to do the internal armor, or do the internal armor before you put the components in, because otherwise the components get in the way. The next step I'm going to complete is to install the drive shafts and motors. So for that step, you'll have the drive shafts that come with the prop attached already, and then to install it, what you'll have to do is grind a flat spot on the end of the shaft, so the gear that goes on there has something to bite onto. For gear selection, most of us will use a 32 pitch gear. Here's one. 27 tooth is a pretty good diameter. It's just about as large as you can get. So what I've done here is I put these little bushings right here just because of where the stuffing tube was relative to the plastic, which is how I assembled it. Nothing really wrong with the kit. So I put this little, I made these little bushings here, and then I put a mark so I know where I need to cut the flat space. So I'll just do that with a Dremel cutoff wheel. Here is a close-up of the flat space. I will cut these pretty deep, kind of see there, give it a nice good flat area to provide contact with. This is a 5mm shaft, so there's plenty of diameter to work with. Sometimes if you do this on like an 1/8" shaft, you need to be careful not to cut too far because it'll actually impact the structural integrity of the shaft itself with the forces of the gears that we use, and it can bend the shaft. So this is done. So next step is really install these. With that, I'll also be lubricating the stuffing tubes. I use marine grease to grease the shafts. I use this item to inject it into the back of the stuffing tubes. This helps lubricate the bushings, and it also helps prevent water from leaking in through the stuffing tubes. So that's in. I'll put the shafts in, and then I will attach the gears. I installed the gears to the shaft, and for that I'll use blue Loctite on the set screw to prevent it from coming out during vibration. Loctite is required here, or else the set screw will come loose. Blue is good because it's removable, because eventually you will need to remove the gear in case like a prop breaks or something like that, and using something like red or stronger Loctite can be more difficult to remove, and you'll need heat, but blue will hold it, but then it's also removable. Next I'll install the rudders. Do that, cut the rudder post down to size here, and then grind a flat spot on the end so the set screw for the sprocket can have something to bite onto. Now with both sprockets on, just want to make sure the rudders rotate freely, aren't binding against anything, and then use the chain from Servo City and kind of snake it around the two sprockets, and then align with the hub on the rudder servo, and then if necessary you can adjust the position by loosening these two screws and sliding the plate back and forth. Get the chain attached. So first I got it on the two sprockets and got the right alignment between the rudders, and then I clipped it together because I had to snake it through the backside here, and then got it on the servo, and then once it was on the servo kind of pushed the mounting plate out until there was no slack in the chain, and then pulled the servo sprocket off and then tightened down the sliding portion. Next I installed the motors. So for this, similar to the rudder shaft, grind a flat spot for the set screw for the gear to engage, and then you want to set the spacing between the gears. So I'll use a piece of paper and I'll fold it up so it's 3 layers thick. Push it down so it engages, and then I'll tighten it right there, and it'll kind of result like this one, where there's a little bit of space. You can see you can allow a little bit of backlash, so you can move one of the gears slightly, but they're still engaged, and that'll prolong the longevity of the gears. At this stage in the build, I'm going on to gun placement, gun assembly. For gun placement, this boat is class 4, so it can have side mounts, so I'm going to have 2 aft side mounts, 1 on either side, and then a bow gun that's angled 15 degrees off the bow and has down angle. So for guns, usually first thing I'll do is make little mounts to help hold them. So the standard of what the boat comes with is just this gray part, and then I've printed in this black part to help hold the elbow. And then I'll add a little angle piece to hold the barrel in place, which is good because the boats will rub up against each other and it can knock the barrels around. Okay, so with the guns and gun mounting, you want to plan out where the magazines are going to go. Magazines to hold the BBs. I have 2 different style magazines here. This is a plastic tube magazine. I'll end up using these for the aft gun. Advantages are it's lightweight, it's also flexible, and the flexibility reason is why I'm going to use it here, because basically you need to have your deck pieces removable. So I could use a traditional magazine or a copper one, but that's going to be kind of difficult to bend in a tight area. It absolutely can be done. But another feature I want is to be able to reload the guns with this aft deck piece in place. So to do that, there are two options. One is to snake the fill tube up into the turret, which can work good, but it's a little more difficult to do in practice. Option two is to just have the magazines go under this cross member into the front area, which will have to be, like, this deck piece will have to be removed between every sortie, so that's fine. So in this case, what I'm going to do is use these plastic magazines because I can snake them under this deck piece and they're flexible. So getting the deck piece in and out will be easier because I'll be able to kind of flex the magazines as needed. Where if the magazines were rigid, it would be more difficult to reliably kind of get them in. These also have the pump kind of right there, so flexible will be a good option here. You have the guns. I usually have it here, so you have this up tube that comes out of the bottom, and then next the T will attach to that. So it'll just kind of go on like that. So for these, I'll put the T's on, and then I'll attach the magazines, and then kind of identify like where to put a few support pieces to hold the magazines in place. I assembled the guns, and then I also mounted solenoids under the deck using a simple aluminum L piece. And then you can see I printed out these small little supports here, which I'll glue into place, and that'll kind of hold the magazine. That's really all you need in terms of holding the gun in place. The solid black pieces hold the up tube, and then just a couple things on the magazines. If you don't have a piece like this where the up tube's constrained, you'll need more robust supports for the magazines. And then likewise, bow, same thing. It's easier with just one gun to worry about, but have a magazine that go up along the deck to refill, and then solenoid going directly to the gun. For this, I put a number of screws through the deck, so I'll epoxy those in place. Once that's all done, I can assemble and test the guns. Another thing I did was put the magnets in the holes there, both the barbets and the turrets. So I want to make sure you have them all oriented in the same direction. You may need to Dremel out the hole a little bit to get the magnet to fit. For the mid turret and the foremost turret, those are dummy turrets, so I'll just end up gluing those on because the magnets alone aren't strong enough to hold the turrets if they get shot. These ones with the guns should help. The gun will help prevent them flying off. I completed mounting the guns in solenoids. So for the magazines, I print small holders. I put a hole for a zip tie to go through, and then the solenoids have this aluminum bracket, and then I've attached the hoses. So now these are pretty much ready to test. On the stern, I have the deck in place here. Key things are to ensure there's clearance. So it's a bit hard to see with the internal armor. I like to do this step before shooting, putting the balsa wood size on, because it allows you to verify this clearance inside. Alright, so next I'm going to mount the CO2 bottle regulator. Normally will go in the bow or in the middle. In this boat, I'm going to put it in the bow, and then I'll print a support for the neck that can also be made out of wood. Basic idea is to support the bottle with a very slight up angle, and what that does is helps limit CO2 freezing as it goes to the regulator. If you have guns that shoot very fast or shooting multiple guns at a time, Not a huge concern on this boat because it's just single guns, but still something I like to do. So for this, kind of same thing, I'll generally try to push it all the way up into the bow, and then I just want to make sure for how the guns stick down that there's going to be clearance. There's clearance, nothing is sticking up. So I'll glue that in. Now I'm going to test the guns. Do this to make sure the guns are assembled well, make sure they're feeding properly, make sure the solenoids are working with the voltage you plan to use. So the setup here is I got the solenoids hooked up. For pressure, I'm just using an air compressor. You can see just push to connect into a adapter that goes right into the air compressor hose. Just a basic pancake compressor, goes up to 150 psi. I also have a chronograph which can help sort of show the shot speeds, and then I'll have some sort of catching device to shoot into. And then to trigger the solenoid, I'm just going to use a manual switch. You can also do this from the actual boat, but really what I'm just looking for is making sure it shoots, and then I'll sort of check the velocity, make sure it's shooting kind of hard enough. This one, you can see those numbers, they're all in like the 230 range, which is absolutely fine, and that was at 120 psi. Seems to be plenty hard enough, so mainly just checking for, is the gun working, is it feeding well, how does it do under little bursts of shots. So I'll shoot like 4 or 5, and looks like it's out of BBs, so I'll try that one more time. Okay, I reloaded so I can just show some more shots. And then that behavior right there is the gun's leaking some air a little bit, which is expected because the bottom nut doesn't have any sealing on it. So I'll sort of decrease the tweak on it a little bit. Fine. So I'll test a few shots. Seems to be working great. So I'll do this for the rest of the guns, make sure they're functioning.